And just quickly, because I can't see, how many attendees do we have? Skype me, please. Everyone, thank you for attending this morning's webinar. My name is Bob Miller. I'm the CIO here at OASYS. We've been a provider of various multi-value products for actually literally a couple of decades. And this morning we're going to talk about a product we introduced this year called OMNI, an integration framework primarily focused on multi-valued implementations and leveraging many of the Rocket YouTube capabilities to allow for modernizing existing MV applications through the use of services and web components. Our key focus here at OASYS is helping companies extend the life of their multi-value applications. The focus is on how to do that in ways that minimize the risk of introducing new technologies, but innovating how those existing capabilities can be presented not only in different ways, but evolve to new architectures that ultimately will extend the life of those systems. The strategy and the suite of tools we have really focuses on 4 areas. One is opening up MV data to modern BI and reporting tools. There's many different sort of flavors of that, in the industry today. But we'll talk, that's not the focus of this, but I'll introduce some of the ways we handle that. Key to it is opening up MV functionality as robust web-based APIs. There has been many over the years different tools to allow .NET development against calling a subroutine or manipulating MV strings. Our position is, or our beliefs are that opening up a modern REST-based API architecture that is full CRUD, create, read, update, and delete, in ways that leverages the existing business logic is the key solution to that, and that's what we're talking much about today with OMNI. Providing a common platform for how modern teams, that is .NET, Windows, Java, and other teams, collaborate with the multi-value teams. The multi-value teams have all the the sort of the knowledge of the existing application and how a lot of that business logic works, and potentially the new teams that are developing applications around more web-centric or server-centric implementations. These teams have to collaborate, and so what's a platform for doing that? And then strategies really for re-engineering much of these applications for cloud-based use. Now, cloud-based is not just about moving the MV and putting in a hosted data center someplace. It's about shared services. Many multi-value applications are on-premise, meaning they're installed someplace. But many of the vendors and VARs that are building those applications, and we have a couple examples today, find that, oh, wow, I have 50 customers. They're all doing the same sort of operations about loading data or sharing similar data, that it's possible to put many of those applications in the cloud if, in fact, the on-premise application effectively was able to communicate with and utilize those cloud-based services. From a platform perspective, we really look at it as 4 major challenges with an existing multi-value application. First is really the service integration notion, how to take what is effectively very monolithic applications for the most part in the PIC world and structure them and reorganize them into reusable and services that any technology can get access to. The second is really web enablement. Obviously crucial, but that also takes on many flavors. It could be as simple as delivering a terminal emulator in a browser to eliminate the client distribution, but can go on to variations on screen scraping and direct HTML or other coded interfaces. Database integration really focuses on how do we surface multi-value data in ways that are most useful to a broader range of tools and a broader range of users in the businesses. Here we really focus on really 2 technologies. One is around replicating into a data warehouse, and the second is surfacing SQL-based data that is actually bidirectionally accessible and updates the multi-value data. And then in the final hub, traditional for MV anyway, tools that extend environments like .NET, so that .NET developers can access both files, data, and programs within that environment. Again, this webinar is not focused on Bridge, but just to quickly, Bridge is again a replication server, allows for easily mapping both on a scheduled basis and a triggered basis data into multi-value databases. It allows for that data to then be enriched or extended into more normalized views of the data. Each of these with service architectures that allow that data to be updated. Everybody realizes that obviously an MV view of an MV database is fairly complicated, in that absent a lot of the referential integrity that exists in a standard SQL database, it requires application logic to insert an association of MVs or MV based attributes in an array. And so absent that, the connecting this database to the that application logic is crucial. And so we actually use OMNI for that. So we'll talk about that in a second. Web enablement, we have a couple of different approaches here. We partner with a number of companies and have developed extensions to their products around web-based terminal emulation. That, as I mentioned, delivering a traditional 80 by 24 in a browser, and the generation of HTML-based forms from existing terminal emulation screens. There's a number of products out there in the market. We think they all have pluses and minuses, but we think that our coming to the table as a sole provider for modernization, that these were important technologies to have in our quiver. So, OMNI, which is the primary purpose here, and then we'll jump to a demo. Connect MV applications to the cloud and service orient as much as possible of the legacy application. Expose the data and business logic to external applications. That's really around having interface styles like OData, which provides CRUD operations, which really is structured to deliver that type of interface, and ultimately have end users and VARs be able to develop new functionality from these services very quickly. We think that what we're going to show you today is going to offer a couple of key benefits. One is it provides a web-based platform, configuration-centric. It's, there is development utilities involved, but really it's a configuration-centric platform where the people that are creating services and the people who are consuming services can effectively collaborate. And that would be the .NET guys and MV guys, or Java guys and MV guys. It emphasizes configuration, and we'll see how much of that during the demonstration. It properly focuses on the, how to get the multi-value developers focused on surfacing a lot of this business logic in ways that are reusable. So it's an environment that's sort of multi-value centric, but it allows these resources who understand what's going on in the application to contribute effectively. The services, by design, generate a high, because of their ability to be orchestrated or interoperate, a high level of reuse that can be used many times over in different applications, and provides the full life cycle of, if we're going to develop a service architecture that's really great, the ability to introduce new services, publish them, distribute them, package them. So it also contains the full sort of SDLC of how to manage a rapid creation and distribution of those services. So from a high level, given I'll give a little physical view in a second, but the existing multi-value application, OMNI is an account that sits next to your application, does not alter it in any way, and surfaces, depending on the flavor. What we'll look at today is actually a universe-based demonstration. Leverages the native sort of low-level communication and other protocols to then put a wrapper around those that then facilitate different types of message architectures. So in the case of Rocket, for example, has very very effective, low-level components. We're doing HTTP and sockets, etc. They have a sort of a REST API that we've used in the past, but basically we put wrappers around this that allows configuring these, not coding these, to accomplish different message formats. We've extended those with things like OData, which is a type of REST service protocol that really facilitates operations, as well as ETL, extract, transfer, and load, which are file-based operations. We put a collection of tools around creating administrative and application interfaces in HTML and responsive HTML, and we integrated all of the necessary, what we think was certainly necessary administration capabilities around service level management. Every API, creates very, very detailed logging and performance analysis and success analysis, etc., packaging, and then security administration. So it's basically a wrap around the existing application to expose these type of capabilities. We're going to jump into a demo in a second, demo in a moment, but effectively it's delivered as a web environment, leveraging obviously a web server either on or near the MultiValue application, and all of the key logic is actually in the MV account, not external to it. There's a small gateway around that to accomplish the web communications. In the case we're going to talk about today, using Uni objects as the lowest level component of that, but some pieces around that. As a physical notion, just for anybody that kind of cares, there's existing MultiValue accounts. OMNI installs as a standard native account next to that. There's installation and discovery tools. Since OMNI is going to be operating on data, accessing and updating data, there are tools that allow for the discovery of obviously file and other information, and also the installation of OMNI in these accounts, so that legacy applications can actually use OMNI in new applications, so literally call services. And fairly traditional, there's a native connectivity through Uni objects. There's a secure web gateway. This is a suite of Java components, and most of our clients are on Linux and a Tomcat web server. These also install on separate web servers, not necessarily on the same box. So very, very simple. It's very non-invasive. Install the account, click the install discovery, and all of a sudden we're able to surface the data and things that we'll look at. So what we're going to take a look at now in the DEM, the existing application. There are sort of two sides of this. One are how we expose all outbound service definitions. So the ability to, we've implemented about 35 applications so far this year. So different ways that an existing application wants to communicate outbound, whether it be through socket, SOAP, REST, custom interfaces, custom styled web or proprietary interfaces, and moving files in and out. So there's a leg of this which allows these type of features to happen in a configuration-based approach. And then on the sort of inbound, exposing the existing application, there are standard patterns of mapping data, querying data, other types of services and CRUD operations, which are exposed in both real-time services and file-based services. So we're able to define sort of services in a generic way that actually are reused either through queued, file-based operations or through real-time messaging. This is really, we consider this real important. So one interface or one interface definition reusable across different sort of modes of communication, which in many applications the target doesn't have the ability to make a web call, and it's traditionally used to dropping a file in a directory. So common interface definitions, multiple ways to access it. And then if you think about this access, there really are different quote-unquote protocols or different message formats. REST, basically the simplest, generally a JSON payload, generally a URL get or post. OData is a variation on that has very specific structures that allows for communicating update procedures, delete procedures, and generating UIs, etc. So one common definition, different sort of modes of operation, and then different message structures. So a lot of reuse there. So here I am. I'm in a web browser. I'm attaching to a Linux machine that has Universe on it, and a fairly large. This is a client implementation that they allow us to use for demonstrations. A fairly large ERP system that is doing all the things around not only the back of a retail operation, but also point of sale and other features. So just a little geography. OMNI is organized in it's a framework. It's an architecture for developing services, testing those services, quality assuring them, and then distributing them. What we're in is an environment where the people that are configuring those services or configuring the applications that a collection of services create goes, and it's deployed web-based. Really a couple things going on. There's administrative functions around managing or monitoring what in our world are called phantom processes. We can see that there's this stuff running and going on here. These could be running ETL services. They could be running all sorts of different things, but it's a web-based management. You never go to TCL to manage any OMNI features. They're all here in the browser. And various other things, whether it be around managing control records or different configuration pieces. We'll take a look at some of this in a second. There are integration configurations, which are really designing the different integrations that might be used. There's web and mobile development components, so surfacing these services as web content. We'll talk a little bit about each types of service can actually be used to or delivered in different ways. It could be delivered as to make the web call. It could be delivered inside a web page. It could be delivered as a subroutine call, so that there's a lot of reuse there. In building these various, I might build 10 APIs that constitute an application. There's this concept of then accumulating them or associating them together to then be application modules, which are then distributable to clients. This is a retail operation, so the development of pin pads were done here, so all the communications with a pin pad device, managing 15 different vendors of getting buying a digital product, integrating with a point-of-sale system, and some other things. So think about these as the sort of primitive components, and then this is sort of aggregated to be the underlying application. So I'm going to start with real-time interfaces. What we're actually, we call them RTIs, real-time interfaces. They're basically REST-based APIs. And you'll see here a list of different basically services and methods, right? And so I'm going to use the absolute possible simplest version for a second. So here is a service that says take 3 inputs and do an operation. Here we're seeing effectively multiply 100 by 20. This architecture would have been, all right, if somebody would have called this service, posting these or placing them on the URL would get a result. If we edit the service, we can see that there's a definition. At a top level, it says that we're implementing a subroutine. Now, these services are actually templated stubs, which we'll look at in a second. And then there's one method called math. It has parameters. In this case here, they are required parameters, and it has a response. And in this particular case, it has sample data. So when we tested this, all right, we got the benefit of basically a testable version of this, so that for any kind of regression or whatnot, we can easily know that we're exercising the service correctly. If we were to, you're now looking at the service stub, all right? So it's a subroutine, so any MV guy will feel comfortable here. You'll see there's no procedural code in here. It's all a bunch of application events. This is classic throughout OMNI. So it's an initialization, a validation of parameters, a extraction of those parameters, and then work through the application call. In this case, you're doing a little bit of work, and so a slight change here to have the response be a different word than answer. So we're managing source code. This is all managed source code. In this particular case, it's actually managing through Git. So there's updates and pull downs actually going through Git for the supporting this. And so that small change, we effectively altered, this service response within that small body of code. Now, the key to all of this, of course, is capturing the existing business logic. Now, this particular client uses a 4GL, like many do, and in their case, their 4GL has certain operations and things that they require. So they have this, for example, get the details of a customer's AR account. Well, much more complicated message, given a customer number, return a collection of data. Well, if we were to look at that service, it's more complicated because they, in fact, have to initialize their environment so that they can effectively do the same updating, locking, and everything else. So this service is a little bit more complicated, but it's the same notion of inputs and app calls, and they're using some of their own subroutines to manage locking, etc. So this particular client has about 150 services now, supporting about 20 mobile apps and 6 different cloud-based applications. And they were able to do that because they were able to surface their existing data in a way that respected the local application, but now these external developers and external applications could benefit from. There are many, within RTI, there's many sort of component type applications where we see, for example, select a standard file, see, in this particular case, grab the field called merge system, group on it, do some math, so basically analytic services that, in this particular case, returns cubes. This is like totals is 55,000, but department roll-up is something different, right? Here you're seeing a web call. So this is, again, as I mentioned, would have been a developer, somebody making a call and getting a JSON payload. Services also surface. Here we're seeing the same sort of input parameters as utility web pages. So here we're seeing that the results of that literally in a total was this, and the group by department is this. So a lot of flexibility in, again, what we do with these services, but then most importantly, how we test and develop them. Now let's, each, as services execute, there's a whole service level management. This is actually a query engine, web-based query engine against the universe account. But in this particular case, managing, we did a get customer, we did an analyze. Really important. This is, if we're going to create these services and rely on them and have people rely on them, managing them is as important as developing them. So this ability around that. Finally, all of the services also contain effectively generated help. So the documentation of the service is actually auto-generated from the parameters and then edited. That also occurs. in the web environment, so that the developer or the business analyst or technical analyst can keep these up to date, so that anybody using them can actually request, as well as the service can request the documentation on the service. Okay. So there's an example of sort of exposing or outbound exposing different internal data as REST APIs. There are other components, for example, like HTTP services. These are zero code, basically, services where, for example, in this application, there's a requirement to communicate with an external vendor. You see multiple of them here: Copia, Red Shelf, Vital Source. To, in this case here, send a message in order to get a code back, basically a digital authorization code. So that's the vendor specification. Now, if we go and look at Copia's message structure is completely different. They use a posted REST API. They use a JSON payload. So here we have 4 requirements to communicate with an external vendor. If we were to edit these, we can see that the message structure here has particular inputs, particular control information. So what you're looking at here is something we call UMV. The entire, I do mean the entire OMNI database uses a data structure that effectively is designed to an item structure, if you will, that's designed to create a self-described multi-level hierarchy that's compatible with easy translation into XML and JSON. So one of the things we did was take the advantages of MultiValue. I'm going to open up BDT. Again, this client's on happens to be on Universe. We're looking at a Rocket product here. So there's a file called RTI Services. If you recall, one of the things we were looking at was AR get customer. We were also looking at something called a test service, which was the math. Well, if you look at this, this is a classic MP item. It has, again, for it's a little bit technical, but it's a service. It has a method called service and math. Service points to a group of attributes that have all its descriptions of its properties and its data types. And a second one, math, which has, if you recall, the A operator, B, etc. This structure is, and within the OMNI infrastructure, is the internal structure of every JSON and XML payload that we receive or transmit. So from a programming perspective and from a U2 developer perspective, we never deal with those external formats in the environment. Everything is translated on the way in and on the way out into this kind of hierarchy. Now, if you can imagine, and it really is a hierarchy. These can get pretty complicated, right? The customer post-transaction still pretty simple. But all the exact same pattern. Now, why is that important? Well, when we were looking at, quickly back to RTI. When we were looking at the code for this service, we might have seen that UMV get request A. Well, this is basically a hierarchical reference. Multi-node could be many nodes down. So if the request came in looking like a complex XML document, you actually refer to the XML references in something called XPath. You can actually use an XPath expression. But what actually happened was this thing was, on the inbound, was converted into this MultiValue sort of thing we call a UMV. This is a little bit of secret sauce on this, because what it allows the PIC developers to do is never have to worry about the native message structures, and can actually, and this is a UMV set, a UMV get, there's a whole library of those. That makes coding to these external formats so much easier. Just back to sort of how a typical architecture works. In this case here, we were talking about these different formats, and again, each client having their, or each vendor having their own format to accomplish a similar message. Well, these were accomplished by effectively designing an object model, in this case here, a series of properties, cutting and pasting the target message structure. So here, this is what this vendor said they wanted to receive, and then mapping the properties, basically this reference here, mapping the properties onto the message structure, and establishing then any, across the HTTP transmission, any key attributes. And all of this mapping can be done across, literally any data that exists in the on the PIC system. So effectively, this service didn't require any code. We were able to create a map of a message. We were able to bind properties to it, and effectively then expose it as a service that can be reused. Now, it was interesting because obviously from an application perspective, the application developer does not want to, in their 10-year-old point-of-sale system necessarily, try to decide which one to call and how to call it, right? What properties does it need? So this is a great example of, this is a web service that's designed many outbound messages, and then a passcodes acquire says a vendor and a part number. This thing just figures out basically how to call the underlying web call and return then a common message structure. So this is all about abstraction. It's all about creating a service architecture that's actually reusable and that's useful to both the existing application and not. Okay, so a couple other things. There's socket based communications. We've used this for same idea, defining different connection structures, and we've used this to develop MX. We've used it to develop pinpad components to do voice picking, some other things. Chrome administration are for designing. So for example, designing or exposing existing data. There's capabilities inside Rocket for how to map, for example, dictionaries, etc., for doing creating XML packets and whatnot. This is sort of an order up from that. So here's a definition of, let me just say, quick discussion. A customer, his addresses, and this is coming out of a PIC file. There's utilities that actually create these from his orders, his order details, and in the case of being able to then establish an operation that identifies the file, creates a payload from this, and then ultimately allows for the same update and delete operations on it. So big part of the tool. And then ETL. ETL is effectively using the same service definitions, except that they're operating on the transmission and receipt of files. All right, so next up, if we looked at RTI and looked at something like a here's a service that simply goes out and gets all the sales for a given day against this database and builds a collection of sort of analytics around it. So you can see, within the status, there's some sort of PIC referencing, type information there, but bunch of sales data, group by date, group by time of day, etc. So going over to our mobile development. So here's a harness for developing sort of lightweight mobile applications. We can kind of see different apps here. There's a service, an RTI, that actually allows for scanning a purchase order and updating a purchase a receiving log. Well, if we looked at this particular app, we can kind of go right into Pages here, and there's something called Store Receiving, and there's a small little fragment of JMobile HTML. Well, in this particular guide, we see that we are actually referring to an RTI called Store Update Receiving Log. And so what we're doing is embedding RTI services in a server-side HTML environment to create some pretty lightweight and very quick applications, because develop the service and now reuse the service, either because the existing application is calling it, an external application is calling it, or in this case here, a hosted web page is calling it. And so I'm just going to go back to that guy for a second. RTI. Store update receiving log. So this service respects or takes a number of parameters. Sending it actually causes this to be updated in that database. This took 30 minutes. 30 minutes to develop this, and this client never had a handheld scan of something on the receiving log, and take a couple of request parameters, open the PO, update a bunch, because they're using their own obviously equates and references to their file, and they're committing that to that log. Apologize for the fire trucks. So this entire production handheld application requiring no deployment or no client side was developed very quickly in this particular case. All right, and that range of applications, and again, this is a test harness for doing that, combines accessing cloud services through for this happens to be comic book stores, picking up a student, searching locally for their courses, but then this now going out and using a cloud-based service to find all the bibliographic and other data. So the combination of saying in the center of this is a mature multi-value application, but surrounding it with web-based access and cloud-based integration and programmatic service integration, all with one definition. I wanted to show you one quick thing, again, a little technical, but so this is, as everyone knows, traditional zip code. There's in this case here, they have a 20-year-old point-of-sale system, and so OMNI was installed, next to that sales system. Let me just try to get this file here. Sorry. So if you recall that discussion about going out and getting a passcode from any one of these 5 vendors, well, they do that at the point of sale, and so they had to, in their 20-year-old point of sale system, somehow surface that. Well, what you'll see here is a subroutine built recently within this 20-year-old system that effectively establishes a call to one of 2 OMNI methods, and simply does local business logic, but then is UMV setting parameters for the message, and ultimately calling that service. So this is an example of the same, modern service for web and REST APIs being then used or called from inside the legacy system. So I can't overemphasize how important this is. We're developing one abstracted, view of a service that can be used in many different ways. So it can be maintained and in one place and distributed in one way, and then obviously leveraged, by these systems. And so in this particular case, this was a mature, seasoned TIC programmer that didn't have any trouble using Omni and an Omni-based service to extend his legacy application. I mentioned that as part of this, if we think about some of the services we looked at digital, this here is effectively an aggregation of those in one place. So there's a control record that says, what URLs and other things are required for each vendor. That's used in the mapping configuration. The creation of these this is a fully creating new parameters. This is all an interface that all that happens on the fly. You can create new versions of these. You're manipulating what's called UMV. All the related services. So in this particular case, these are the RTIs that are related to this. These are the web calls related to this. This is how the application is packaged. So what it does is it detects from all of those different components what needs to happen if I wanted to move this to a client. This packaging architecture actually performs complete builds of all the related services components, which then actually can be automatically distributed and installed. Again, really important. It's not just about the service. It's about maintaining a lot of them and being able to distribute them reliably. This has a whole source code integrates with Git underneath the surface as part of that. That's an option if the client wants to implement those type of source code controls. But again, this is really important to any specific logging, around that particular application. And here is all of every time we ran this and got a code, no transactions, in production. So each of those, you're building application suites. You're not just building discrete services. You can associate them together and package them together. And that's true across the entire Omni environment is customizable. What we're here looking at is sort of web. If we kind of go to the index page, well, the index page is in fact this page here, and again can be easily modified. There's a collection of tools that generate a lot of this HTML from templates, but in fact, completely surface, completely visible. And you haven't seen me going to necessarily TCL or a lower level editor yet. So okay, just wanted to. The kind of wrapping up on Omni as a framework and some use case information. So we found that one, for example, customer is has about 50 installations of their ERP. They've used it to introduce cloud. They've introduced it to extend their application with a web-based interface for a lot of on the sales floor, in the warehouse type applications. They've done it with effectively their existing U2 development teams who are able to really adapt because of the alignment of this with their MV tools. They've went from being a big release once a year kind of company to almost releasing software every few weeks, because now the ability to basically modularize a lot of these services and applications. It's helped them think. They've retired in their particular case almost a third of their some very gnarly old applications, because they were able to say, all right, I'm doing EDI. Why am I doing that again? I wrote that in 1969. There's services I can use. So exposing many of their processes to cloud-based services, for those purposes. Pardon me. We have another client that is trying to get his application down to the big enterprise application, but he's trying to. There's really important things in it around how they do billing analytics and some other things related to healthcare. And in their particular case, they are trying to take all the core, really important software and set it almost into a service hub. So they're using OMNI around that to say, okay, I can do that, and I can basically just stop using other code. I don't necessarily have to, materially restructure that application. I can put an OMNI wrapper around it and publish these services for bidirectional update and retrieval. We have another one that is really focused on how to deliver a cloud-based offering. Their 60 clients they all do the same thing. They all load the same data from the same vendors. They all kind of repeated processes. So they started offering a cloud-based service to say, we'll aggregate once, and then through OMNI, the application now reuses all that data. So they've basically taken those local databases, out of their application. So there's a lot of different use cases, a lot of different ways of thinking about the service orientation of our mature applications, and OMNI is really targeted at solving those. So I think that kind of concludes the presentation format. If anyone's got any questions, I'd encourage them just to hit that chat window. I'm happy to. I probably should have mentioned that at the outset, but I'm happy to kind of address any of those. If not, we'd welcome the opportunity to reach out and discuss a little bit about your particular challenges in this area of sort of opening up your system and the different techniques that we have to do that, and different tools we have to do that. So we look forward to being in touch. Thank you for attending today's webinar.
Bob, you have a question.
Oh, I'm sorry. I don't see it in my.
Look, there's.
You want to read it?
Yes. How do you authenticate users of the published web service? This is from Matt.
Okay, so this uses native authentication on your, in this particular case, Linux system. So we actually, however you're authenticating users to that system today, you continue to do it in the future. You create local users. Those users can also, the way the authentication services work, there's actually literally is an authentication service, which then allows for basically validating those. So it supports both an end user through a web call, but it also supports persisted. I'm sorry, persisted tickets that can be reused by peer-to-peer or system services. This is how all the integration with the cloud services work. So guy goes from, he's locally logged on to MV app, he goes out to links to cloud app using these services. Cloud app uses basically SSOs him, single sign-on, and so it allows for a full single sign-on architecture. I can't see them, so if you'd
sure, that
shout that.
Yeah, that was the only question. Anybody else have any questions? Okay, I don't see any more questions, Bob. So.
Okay, great. Again, thanks everybody for attending.
Thank you.
We'll be in touch.